Hi friends, welcome to this video on central limit theorem part 4. We have been using central limit theorem to estimate the value for or the probability of x bar and Sn. X bar represents the average of the random variables and Sn represents the partial sum of the random variable. We'll quickly move on to problem. If x1, x2, x3 up to xn are Poisson variate with parameter 2, use central limit theorem to estimate probability of 120 less than or equal to Sn less than or equal to 160, where Sn is x1 plus x2 plus x3 up to x75. As we have said, our central limit theorem, which has been asked to be applied, can be used for estimation of two kind of data. One is x bar, the other one is Sn. When you have x bar, you will be searching for keywords called as average or mean. When you want Sn, you will be searching for keywords called as sum or total. Over here, in the problem, they have directly given to us the problem is on Sn. So, we are going to use Sn in the central limit theorem. So, our step 1 will be choosing the formula corresponding to Sn. So, let us recollect what is the formula for Sn. We recollect that Sn follows normal distribution with mean value to be equal to, so the mean of the data is going to be equal to n mu, and the standard deviation of the data is given by sigma into square root of n. Recollect the formula. Sn follows normal distribution with n mu and sigma into square root of n. Now the requirement for this formula is n, mu and sigma. So we will have to collect the data from the given question. What we know about our n? I have been given Sn and x1, x2, x3 up to where does it vary? x75, which means my n is equal to 75. So the first quantity or the first data has been obtained. What are the remaining two data? I need my value for my mu and I need the value for my sigma. How to get these two data? Now, we'll have to again go back and check our question. The data says that x1, x2 up to xn follows what distribution? Poisson distribution with parameter equal to 2. We have to recollect that the Poisson distribution is given by probability of x is e power minus lambda, lambda to the power of x divided by x factorial varying for x between 0, 1, 2 up to infinity. What is lambda over here? Lambda is called as the parameter of the Poisson distribution. So this Poisson distribution has a speciality that the parameter is the same as your mean is the same as your variance. In which case, what has been said about our parameter? Our parameter has been mentioned as 2. So, we say that this value is equal to 2. Hence, what do? We fix mu to be equal to 2. Next, what is variance? Variance is sigma square. Sigma square is 2. So, what will be sigma? Sigma will be square root of 2. You will have to be very cautious over here. If this point is missed, then the entire problem will go wrong. Okay, so we know parameter is the same as mean is the same as variance, which is being given as 2. Therefore, mean is 2 and sigma, the standard deviation, is square root of 2. So, step number 2 is over. What is our step number 3? Fix your data in the formula. So, Sn follows normal distribution with n mu. What is n mu? 75 times of 2 and sigma into square root of 2 into square root of n. What is square root of n? Square root of 75. So, Sn follows normal distribution with 75 2s are 150, comma 75 into root 75 into root 2 will be root 150. So this is going to be my mean and this is going to be my standard deviation for my Sn. Now step 4. What is my step 4? I'll have to fix the problem. What is the problem given us? The problem requires us to estimate the probability of 120 less than or equal to Sn less than or equal to 160. So this is my question. But I cannot solve the problem as such in Sn. Therefore, what do we do is convert the problem into Z. So this 120 has to be corresponding to a value in Z, and this 160 has to be converted to the corresponding value in Z. What do I know about Z? Z is the standard normal variate given by x minus mu divided by sigma. So it is x minus what we have in place of mu. In place of mu, I have it as 150. And what do we have in place of sigma? In place of sigma, I have it as square root of 150. So this now x takes the value 120 and 160. So we will compute the data. So I want 120 less than or equal to Sn less than or equal to 160. So in Z, this must be equal to 120 minus 150 divided by square root of 150. This goes over here. 160 minus 150 divided by square root of 150. This goes over here. Use your calculators to estimate these two values. You can obtain it as minus 2.45 and the upper limit to be equal to 0.82. So, my step 4 is over. What is my step 5? To draw the normal distribution graph and identify the region. We know that the normal distribution graph is going to be a bell-shaped graph. So, construct a bell-shaped graph. Now, what is going to be the center line of this graph? The center point is measured as z is equal to 0. This graph varies from minus infinity to plus infinity. Where will the point minus 2.45 lie? It will lie in the negative portion of z. So let me plot minus 2.45 over here. So this is going to be my value. Z is equal to minus 2.45. What is there on the right hand side? 0.82. Where will 0.82, which is positive, lie? In the positive point between 0 to infinity. So let me point this as my value. Z is equal to 0.82. The requirement is the region between these two quantities. Hence, we shade the required region to be this portion between minus 2.45 to 0 to 0.82. So, this is my required portion. Now, how to estimate this using the normal distribution chart? Now, this portion which is negative can be flipped and taken the mirror image of so that we can have it to be equal to probability of, first we will try to rewrite this in terms of region 1 and this is my region 2. Okay, region 1 is from minus 2.45 less than Z less than 0. And what is region 2? It is between 0 less than Z less than 0.82. Now this portion which is in the negative part can be rewritten as 0 less than Z less than 2.45. And how is this by? This can be done by the nature of the normal distribution chart which we know that is symmetric. Therefore, you flip and take the mirror image of it. So, it is 0 less than Z less than 2.45. And the second region is as such 0 less than Z less than 0.82. Now, look into the tables and estimate the data for these two quantities. The requirement is 0 to 2.45. Where is our 0 to 2.45? 2.4 is over here and 5 is over here. So 2.45. So this is my 2.45. So the value for my first data will be equal to probability of 0 less than Z less than 2.45. So this will now give me the table value as 0.4929. What is the second data now? The second data is 0 to 0.82. Where is our 0.82? So we will search for the second data. 0.8 over here and 2 over here. So what is the table value? 0.2939. So the second value 0 less than z less than 0.82 will now give me the value as 0.2939. So the total probability will be the addition of region 1 and region 2. So add the data to get it as 0.7868. So the probability that 120 less than or equal to Sn less than or equal to 160 will be equal to 0.7868. So this completes the problem. Thank you.